everybody. Today I wanted to go over some things I've been doing inside of Niagara. I'm using the latest version 4.26, and what you can see here is that I am controlling the origin of my Niagara particles spawning, and then I am having them trace, while this guy is moving, the outline of what this character mesh looks like. And so you can see as he's moving, the particle's final destination is also moving. One of my viewers, Colby, thank you for your question. He asked me how he can, very tightly control where particles are spawned and also stop spawning them when they are not, when he doesn't have any spawn points available. So I'm going to go over these items, and I hope you find this interesting. Let's get into it. Okay, so one of the first things I wanted to show you is a Niagara module script I created. It's called cache spawn. In this script, what we're going to do is we're going to accept a few parameters here. So there is a point array. So this goes back to the concept of the custom set of points that particles will spawn at. We're going to pass that in as a vector array. The position, this is controlling which of the points we choose to render, or where the next particle will spawn at. And then a skeletal mesh. So the skeletal mesh we're going to use to get a random point on the mesh. Let's go back here. Go back to the thing. So if we're looking at the mesh, we're going to pick a random point along his body, wherever that may be. And then we are going to, the particle that we create, so we're going to find a random tri-coordinate. We have the random info. I've covered this in a previous video if you want to look that up. But you basically grab a random triangle coordinate, and from that coordinate, we're going to find its position in the world. And then from there, we're going to offset that position by 200. So in our case, the X position will move it to the right of the model. You'll see that. And then we're going to store that as our target position. So then in our emitter, we're going to navigate from the current position to the target location using a smooth lerp. And that's how you get particles to move. The other thing that we're doing here is we're finding from the point array. So these are our spawn points for particles. So this will get passed in from a blueprint. And what I'm doing here is I'm taking, I'm lerping, so between 0 and 1, from 0 to the last index in the array. So if there are like 3 indexes, it goes from 0, or 3 points, it'll go from 0 to 2. So then your lerp value is the position that also gets passed in, and I'll show you how we populate that. So from there, I do a get on that array of points right here, and then I take that as my starting position. So this is going to set the starting position for our particle, and then we're going to smooth lerp to our target position. The last thing is I'm using this to grab the color of the mesh at that particle start point. So the random tri-coordinate, I take the coordinate, I go GetTrUV. I learned this from CG Howe, by the way, who is really amazing at doing Niagara. You convert it to a vector 2D, and then you're going to take this and set the particle's dynamic parameter, material parameter. This value will get passed into a material. Let me show you that. So in our material, I just took an existing material, the flare material. It comes with the default with Unreal Engine. It's M-Flare. All of this stuff basically gets you to have a kind of ball like this for your for your particle. And then here's the part where I grab the color of the skeletal mesh or the texture. So this dynamic parameter we had passed in earlier, this got passed in from within. Let me show you again. Here is our TriUVs. So this is getting that triangle's UV coordinates. We convert it into a vector 4 because that's the type of our dynamic material parameter. So this parameter here is getting passed into our material. We convert it into a float 2 for X and Y only. And that is because we're just using it for the U and the V. And if you look at this texture sample, this is the texture for the coloring of my clown texture. So if you look, right, so his diffuse coloring is this right down here, right? So if I take the UV coordinates from that texture and plot it on here, I'll get the color of that texture at that point. So then here is our module script. The module script is either setting some initial positioning or updating the target location in the dynamic material parameter. Then we have our material. So we go back to our emitter that we created. And let's just show you. So here is our cache spawn. So this was the module script I created under default, right? Cache spawn, I actually have a test one there, cache spawn. The properties on this, we have a set of user points, which I'm linking to input, right? So user points is input and also the skeletal mesh. So I tie the skeletal mesh to our inputs, the points array to our inputs, and the position, remember that was the lerp that I used to figure out which of the point I will choose. I just choose a random number between 0 and 1 as our lerp value, and that will choose one of these points by lerping it. Okay, so that covers that part. The next thing is the position. Oh yeah, so this is the updating, moving the particle from the start position to the end position or the target. So this is pretty simple. In your particle update, you do smooth lerp over vector for the particle position. The convergence rate is how quickly it moves. Smooth value is the current particle's position. And then this kind of gets blocked off here. Or maybe I could move this one. Target location. So I just linked, right, to an existing value, which is the output of our, or sorry, it's under particles, target location. So this particle location, that's the target that we're going to move to that we calculated from the mesh. So the only thing that's left is we had to add a renderer. I added a sprite renderer. I chose the material that I had created called mClown. And that is pretty much it. So then when we go back and we run this, let me show you. So let's go back and look at what's happening here. So we have a particle point that's moving up and down. It's shooting out a particle which is traveling to the target location. You see that the colors are lining up with what he looks like. So it's sampling those colors off of his mesh. And then as he's moving, the target is getting updated, and you can see that as he's walking back, we're now shooting or like spray painting these particles to where his current location is. And then because of, what's the right term, root bone animation, all that, I'm not going to get into that. He jumps back here and then we start all over again. So you can see this thing is moving up and down. So let me show you how I do this part, and then we're pretty much done. So let's go back to our blueprints. Back to our blueprint. Here is the blueprint that I created for our man here. And so this is just a standard blueprint. I created two things, a point emitter. So this is our particle system, our Niagara particle system. And then this is a skeletal mesh component. So you see what's happening here is, here's the skeletal mesh. And then this is our Niagara. This is our Niagara emitter, which is doing what we wanted it to do, which is start emitting particles of the color that it sampled it from, and then shoot them and have their final location stop where the mesh is outlined. So this is actually working, as expected. The only part is so that when we begin our play, let me show you the things I'm doing here. It's a little crazy, but I think if you follow me, it'll be just fine. Obviously, I did this ahead of time because it just kind of takes a while to get through it. So let me dig into this. The first thing I do is I set a timer, and this timer basically shows how frequently I'm going to update. And I'm going to get into what this entire section does right here, but let's move on. So the first thing I do is set a timer, and we'll cover what that does in just a minute. Then I set the skeletal mesh component. I set the this is our Niagara system, right? So I drug this down from up here just like this. And this point emitter system, I'm setting a variable, which is the Niagara skeletal mesh component. So if we go back to this, it's this guy right here. I'm setting this variable, okay? Next thing, you have to give it the name, so skeletal mesh, and then I'm giving it the skeletal mesh component object reference, which is this guy right here. Right, so zombie walk, it just points to a skeletal mesh, and that skeletal mesh is using this material. The next thing I do when we do begin play is I take zombie walk, which is our skeletal mesh, and I play an animation on it. And as you can tell, little Halloween theme, this is Thriller Part 3. So I got all this from Mixamo. I've got some other videos about that, or you can go look it up. And I'm going to loop this animation indefinitely. And just so you know, I did slow down that animation a bit, just to make it a little easier to see some of the transitions. Okay, the next part where I'm updating the point that the particles are spawning from. In this case, what I'm doing is I have an array of vectors, which is the point array that gets passed into our Niagara system. I clear that array, and then what I do is I add a single point to this point array. Now, the way that I wrote the logic in the Niagara module script, you can pass in multiple points here, and it will spawn particles from a random choice of the points. But in my case, I only pass in one point in my array. So the array only has one item. So this is actually pretty simple. So all I'm doing is, if you remember, it's moving up and down. And so in order to do that, I take the location of the actor, and if I just started from there, that is between his feet down here. So if I went up from there and down, it would be in the floor, like underneath the floor. So what I do is I offset it. I offset a little bit higher than what he is. So I take the actor location, I add to the z-axis a radius value, which is just a variable. Earlier I was doing circles, so I had a variable called radius. I'm just reusing it. But it basically is how high and low that motion goes. So if you have like a radius value, like the default is 150, so it's going to go up 150 and then down 150. So because of that, I add 150 to start with, so it's off the floor. And then what I do is, this sine is not getting passed. I take the sine radians node, and I pass in the get game creation time. This will output a value between -1 and +1. I multiply that by the radius. So we're either going to go from 150 back to 0 down to -150. And I add that value, or that value that I get out of here is going to get added additionally to the z of this output. And then I offset it to the right, or by the y direction, by 100 variable, or 100 pixels. And that way, or not pixels, it's 100 units, Unreal units, which is centimeters. So if I look at this guy, right, I'm going to, when you run this, it's offsetting these values this way. So in the y direction. Actually, that's kind of, oh, I think it's because of the way the particle system shifts. But yeah, so it's offsetting by 100, and you see that the particles are going up and then down. And that's because of that sine motion. So sine is positive and then negative, positive, then negative. It just keeps going back and forth like that. Then what I do is I get my point array, and when I'm done with that, I store my point array. The name of the parameter is points. That was in my point emitter, right? So right here. And then I pass in my array. So now the Niagara system has all the data that it needs. It's getting updated regularly. And then when you run it, it's constantly cycling. Let's go back to this. Oh yeah, so if I pause, you can kind of see. So if I pause right here, it's offset everything, right? That was just the location of where my starting point was. This is the point that got passed in our points array. This is the starting point for the pixels, and then they smooth lerp to their final destination, which we calculated by taking a random sampling of our mesh here, getting its color, and then we store that on the particle, right? And so we smooth lerp from this point to that point using that color. So as he's dancing, this is constantly getting updated. And then you can see the translucency of the particles. I'll show you the particle settings real quick. And then I'm going to show you a couple more tips or issues that I ran into. Yep. So here he goes. He's going to turn around. And then as he's walking, it's tracing his outline from here down to the location where he's at. So it's just kind of a cool effect, right? You know, it's depending on what you're doing and what kind of game you're doing. This could be an effect just as a opening scene or something like that. But I think you get the idea. There's a million things you can do with Niagara. Hey there, I just wanted to show one more thing where I said you can have more than one spawn point. So the way that we wrote this, we had that point array. Let me show you how we are going to update that. So back in my blueprint, currently I just have 1 point getting added into our array. So I added some additional code here. And what we're going to do is we're just going to drag this down here. And what this is doing is I added 2 more points to our array. The first one is 300 units down the x-axis, so we're going to move it. And then we're going to go half that distance and go up in the air by 50 units. So now what we're going to have is we have 1, 2, 3 different points that are going to be added to our Niagara system. And it's going to choose one of these 3 points randomly to initiate the particle from. And you'll be able to see that right now. So let me pull this up, go ahead and hit play. And now what you can see is now we have 3 different points. So here, here, and here, where those particles are emitting and doing the exact same action. They're just showing up and coming out from different areas. So really, you can do this so many different ways, right? I mean, you could, as long as you can construct an array of points, then that can be your spawn points for your particles. And additionally, if we go ahead, let me show you this. I'm going to go back and if we didn't add any points here, right? If we just chose, for whatever reason, logic in our game, we don't have any points added to our Niagara array. If we go back and look at this, our spawn rate is tied to, this is our spawn rate. And remember, we lerped between 0 and our max, which is 2100. So we did this. Let me just recreate this, but make float from integer and then get vector array count. So these values here, so I get the vector array count, I convert it to a float, and then that's my alpha. So if there's no points, you have an alpha of 0, so you're not going to have any spawns. If you have anything greater than 0, it's going to spawn at this rate. So just a very simple way. Anyway, I just wanted to make sure that we saw that the multiple spawn points and the point array was actually being used instead of just using one point in our array. But yeah, it looks pretty cool, huh? Yeah. All right, let me show you a couple more tips and then we're done. So the first tip is, within the cache spawn, you are going to see that this RandomTriCoordinate. So this is a function that you can call on a skeletal mesh or static mesh. And it's basically sampling the mesh and outputting a point coordinate. The thing is, you have to create a random info structure. And the only way to do that is that I'm aware of so far is you call GetRandimInfo. The thing I noticed is that in 4.26, this is not available. You will not see it. If you right click and try to type GetRandimInfo, you won't find it. So what I did was I found where they stored it in the engine. Okay. So if you look, it's under Niagara content and functions. And what I noticed was, if you look at this, it will say library visibility. And in this case, it says library. So when I open this up, the library visibility by default, you see by default, it is set to unexposed, and therefore it doesn't show up. I don't know exactly why they hid it, but all I did was I changed it from unexposed to exposed, and then I could use it again. So maybe there's a better way of doing what I'm doing, and I'm just not aware of it. But for right now, it seems now, yeah, that's how I did it in this case. I did note that there is a make rand Niagara RandomInfo. This is available, but I did not understand what seed values to pass in. So maybe if I just look at this more and I'll understand exactly what they are doing, and then I can just go ahead and create my own. So I don't know. It just seems easier if they would provide this function as public, because it does look a little complicated, but I'll have to dig into that some more. So anyway, if you run into that problem, this is how I got around it. Change the visibility to exposed. And you're changing, the engine technically at that point, but at least you'll get it working. Let's see, what other issues did I run into? Yes, I have a great issue. So the whole business about the dynamic parameter that we pass in with the UVs of our sample coordinate, and then sampling the texture from our mesh so that it can have the colors, right? So when you're creating each particle, we're assigning a color to it. And that color currently is coming from the UV coordinates that are passed in right here. And then we sample that texture. So that is where those are coming from. I noticed that I had a problem where this was not working. By default, the material that I copied this from was M Flare. And that material starts off with the blend mode of additive, and it's also unlit. When you do this, despite the fact that you're passing in a dynamic parameter with the UVs and you're sampling the texture, if you set the emissive color to this value, the output that you're going to get looks like this. Everything is just a white color. And I noticed that this was a problem for other people, that they kept saying, I don't understand why everything is white. I'm sure I'm doing everything correctly. And the fix for this is that you change your material first to default. Actually, I realize now that you can change it to unlit, but I think if you just change it to translucent and possibly opaque, so let's value, yeah. So if I change it to translucent, everything's working properly again. Now let's try opaque. I'll apply that. Opaque also works, but you notice I get the blockiness because I'm basically not masking out the parts that make it sort of that particle ball look. So there you go. So additive is not going to work in the case of the texture sampling. So 2 little tips there for you. I hope you enjoyed this video. I know that I covered a lot in here, and Niagara can get a little intense with respect to tying it together with the other systems like materials and using the module scripts. But that is kind of the beauty and the power of it, is that you can really do some incredible things. One other new feature that I'll probably do a video about as well is that they have a new renderer which allows you to render almost anything as a particle, which is truly incredible. That feature is called, let's go back to it. So if we go back to our point emitter, this new feature is called a component renderer, And hopefully I'll come back around and try to make a video out of that. But really, really cool technology there. So thank you. I hope you learned something today, and I hope you enjoyed this video. Hit that subscribe button, hit that like button, and have a great day in the Sine. Thanks. Bye.